So we're talking a large 300 kilowatt plus solar system, 3 different kinds of inverters, 2 different kinds of panels. You saw part 1, you saw part 2. Now what more information can we extract out of this data? That's what part 3 is about. Let's get stuck into it. Hi, I'm Veli from Greenwood Solutions. In this presentation, part 3 of the 3-part series on multiple inverters and multiple panel large-scale commercial solar design, we look at a little bit more nitty-gritty details of what you can extract data-wise. Now, if you like what you see, hit that subscription button. And if you want us to make more of these videos, hit that subscription button again. Let's get stuck into it. In part 1, we looked at how to create a spreadsheet for larger commercial solar projects in regards to panel inverter configurations. And then in part 2, we examined how to extract the various data, inverter and panel specs. And in this final presentation, we'll put it all together with a case study of a system that uses 4x inverters and 2x panel types with a system size aim of just under 320 kilowatts. So let's get stuck into it. Step 1. Select your inverters and enter the details. In this case, we have inverter option 1 and inverter option 2. One's 100 and one's a 30. Step 2, select your panels and enter the details. Again, like the inverters, we have 2 panel option sizes, a 445 watt panel and a 450 watt panel, both Acme brand. Thanks, Mr. Roadrunner. Step 3, we create formula to measure the VocMax. Step 4, we create a formula to measure the VocMax with a buffer. Now I've put a buffer in there for those who are very conservative and are worried about the actual VocMax after allowing for temperature. With a buffer you can make it larger than 1 to further give yourself a bit of a safety margin if you're unsure about the actual lowest temperature on site. Step 5, first inverter, option 1, panel option 1, and we can see the inverter option number 1, inverter number 1, and the solar panel option number 1. Step 6, create formula for the signage, so we can automatically create the signage that goes on the DC isolators and in other areas if required. Step 7, we create the formula to reference the details of the panel. And you can see here the VocMax with buffer, the VocMax of the string, and the VMPP of the string. Step 8, we select the number of panels in a string. In this case it's 24. It's a very high VOC on this particular inverter. Step 9, we make sure the DC to AC ratio is not exceeded. We can do that with a formula. Step 10, we do the same for inverter 2 and for inverter 3 and inverter 4. Hang on, we've exceeded the DC-AC ratio, and I've done a bit of conditional formatting in this particular case. So step 13, we fix the DC to AC ratio. And that's better. We've reduced the number of panels per string. And you can see we've gone from, in the previous slide, 23 panels per string to 19 panels per string. So we've gone from 41.4 kilowatts to 34.2 kilowatts. Step 14, create the formulas for the summary of inverter 1. So you can see the inverter number, we reference a cell, inverter option number, brand, model, capacity, etc. Now we're using quite a few formulas there, so spend the time having a look at those. Now with XLOOKUP, it's only available in the most recent iteration of Excel. You can use a VLOOKUP, which is I think acceptable all the way back to 2010 Excel. We've used the max function, the SUMIF function, the COUNTIF function, and various combinations of those. Step 15, extract the summary of inverter 1. And we can see here, it's a Huawei model test 1, capacity of 100,000 watts or 100 kilowatts, amount of solar in kilowatts, DC-AC ratio string with the highest VOC max, we're all the same, so that's going to be applicable to all of them. The total current in amps, panel brand, and the wattage. And then we extract the summary of inverter 2, same process. And inverter 3, you can see that differs from inverter 1 and 2 because now we're using a 30 kilowatt inverter. And inverter 4 is another 30 kilowatt inverter. We've collected all the relevant information for each of the inverter panel combination, and now we need to put together a summary of the summaries. Step 19, list inverters used. So we've got inverter number 1, number 2, number 3. They're all Huawei, and inverter 1 and 2 are the 100 kilowatt versions, and inverter 3 or 4 are the 30 kilowatt versions, and there's one of each, so there's 4 inverters in total. The panel number 1, number 2, number 3, so that number 1, number 2, number 3 correlates with inverter number 1, number 2, number 3. You can see there the different panel models used and how many are used. Step 20, list the panels using formulas. So you can see now that this is the formula that I've used to extract the relevant information to create panel number 1, number 2, number 3, number 4. Step 21, find the inverter and panel brands. Now, it's a bit of a complicated formula, but when you look at it, it's basically an XLOOKUP that's been wrapped with an offset as well. And that was just because I had to use the offset function because of the way I set up the actual raw data. Step 22, same process for the model details and amounts. And you can see model, how many, same kind of formulas. Step 23 is a finished summary of the inverters and panels, which we showed you before. Any more we can do? Yes, we can work out how many actually goes in a box. So this is from an ordering perspective. Number of full boxes needed and extra components needed as well. So step 24, number of boxes needed. And you can see with Acme number 1, there's a total amount of 288 and the amount in the box is 30. So you need 9 boxes and an extra 18. Acme number 2, number of items 3, you'll need 424 of those, 30 per box again, 14 boxes, 4 left over. Now obviously with inverters you'll need 2 of the 100s and 2 of the 30s, and the amount in the boxes, obviously there's 1 inverter per box. Number of full boxes for both is 2, and extra components needed 0, 0 of course. Now, a little bit extra, what about the total combined current for all the 4 inverters? Because obviously you need this for your signage on the site. So we've used a SUMIFS formula there, and you can see that there, and the combined current turns out to be 361.5 amps. And some more. So what is the highest VOC max of any string on the project? So I've used the max ifs function and extracted that the string with the highest VOC max is actually 1,284.51 VOC max. The most important thing is to use your time wisely and efficiently, and having certain tools at your disposal can help a lot. And good luck on your next project. Thanks so much for watching our presentation on large-scale commercial solar inverter panel design. That's a mouthful. I'm Veli from Greenwood Solutions. If you like what you see, hit that subscription button. And if you have any questions, any inquiries, any answers, hit that subscription button and get in contact with us as well. Look forward to producing more renewable energy videos and articles of interest, hopefully. Bye for now.